Let's talk about the mean. We're going to review the characteristics for the mean and talk about the formula for calculating the mean. So the mean is the arithmetic average. When we're talking about the mean of a population, we're going to use a new symbol, and that is the Greek symbol for mu. So population, when it's indicated with this mu symbol, means that it's the mean of the population. When we're talking about the mean of a sample, we're just going to use a capital M. And we only use the mean as a measure of central tendency for interval or ratio scales of measurement. We can't find the mean of a nominal scale or an ordinal scale. So here are two different formulas that you're going to want to remember. The one on top, because it has a mu, means the mean of a population. And basically what we do is we sum up, that's sigma for sum up, all the scores and divide it by the total number of scores. That's how we find the mean or the average. You'll notice that when we're talking about a population, we have a capital N in the denominator. That means that it's the N of the whole population. But if we're talking about a sample, we have a capital M instead of the mu. We still have the sigma sum up all the x's, or all those scores. But this time the n is denoted with a lowercase n. So it's a small n, which means that this is a sample. We have an alternative definition of the mean, and that is the amount that each individual will get if the total were divided equally among all the individuals, the n, in the distribution. So let's think about it with this pizza. It looks fantastic, doesn't it? So what we do know is that there are, let's say that the total of all the slices is 8. That's the EX, or the sigma x is 8. And let's say that we have all the individuals, let's say we have 2 individuals. Well, if we have 8 slices of pizza and 2 people, what is the average number of pieces that each person gets? It's 4. So think of it as the amount that each person would get if something were divided up equally. So let's think of this. Let's say that we have these 8 slices, and now we have 4 different people in the distribution. So the average that each person would get is 2 slices. 8 divided by 4 is 2. Think about that for a little while. Ponder over it. Maybe go have a pizza. All right. Another alternative definition for the mean is the balancing point of the distribution. This point, I think, is fascinating. So it's located, the mean is located between the highest score and the lowest score in the distribution, right? It can never be outside the range of scores. The mean balances out all the scores. So we're going to use this illustration here. We have 2 children here. It's kind of an old drawing, and they're about the same size. And so the mean is in the middle in this case, because half of, we'll call the weight of the children the scores. Half of the scores are on one side and half of the scores are on the other side, and the mean is directly in the middle. It's the balancing point between these 2 children. But if you have an older child balancing with a younger child, what happens to the mean? The mean gets pulled to where there are more scores. It's still the balancing point, but it's been moved, hasn't it? Think of this as a skewed distribution. We have more scores, so to speak, on this side and less on this side. So as such, the mean is being pulled over in order to still be the balancing point. If the mean was still in the middle, what would happen? Well, the smaller child would go up and the larger child would go down. It would no longer be the balancing point. So the mean is the balancing point. And as such, think of this as the mean. It can never be outside of the highest score and the lowest score, right? Okay, so we're going to talk about a couple different rules about the mean. Changing any score in the distribution causes the mean to be changed. Okay, that makes sense. There's another rule. When a constant is added to or subtracted from every score in the distribution, the same constant value is added or subtracted from the mean. We're going to kind of work through some examples of this. So whatever is added to every score in the distribution, it's also done so to the mean, and it's the correct mean. So the same principle applies for multiplication. So let's take a look at what this looks like. So a sample has a mean of 25. If one person with a score of 25 is added to the sample, what effect will it have on the sample mean? Will the mean stay the same? Will the mean decrease? Can we not determine with this information, or the mean will increase? Think about that for a second. Pause if you have to ponder. And the answer is the mean would stay the same. Think of it as every person has a mean of 25. So if you add one more person with a mean of 25, it doesn't change that mean at all. The mean stays the same. If you add a score that's equal to the mean, it will stay the same. Here's another one. A sample of 12 scores has a mean of 8. What is the value of the total of the scores for the sample? So think about the pizza example. The mean is the amount that everybody would have if it were divided up equally. There are 12 people and everybody has 8. So what is the value of the total? If you have to pause the computer, go ahead and do that. The total is 96. Think of it this way. I have 12 people and each person has 8. 12 times 8 is 96. So that's how we can do a quick multiplication. We don't even have to think about pizza on this. We can just multiply the n by the mean to get the total of the scores. Okay, a sample of 7 scores has a mean of 5. All of the scores are doubled, so what is the new mean? Is it 5? Is it 10? Is it 25? Or can we not determine it with the available information? Think about it. And the answer is 10. So why is that? Well, we talked earlier about if you add, subtract, or multiply every score by the same number, you can just do that same action to the mean. So when we double a score, what are we doing? We're multiplying each score by 2. So if we multiply each score by 2, all we have to do is multiply the mean by 2 to make it work. So we multiply the mean of 5 by 2 to get 10. You might want to try this out. Take 7 scores and the mean is 5, and multiply them all by 2 and see what kind of a mean you get. Okay, a sample of 10 scores has a mean of 10. This one's a little bit harder. I'm just going to say it. If one score is changed, one score, we've been talking about changing all of the scores, but this is just one score is changed from 12 to 2, what will be the value of the new sample mean? Okay, let's think about this. So a sample of 10 scores has a mean of 10. We changed one score. So how do I figure this out? Well, first of all, I need to find out what the total of all the scores is, because I'm going to be doing some subtraction, right? So I had 10 scores and we had a mean of 10. So that means that the total of our scores was 100. One score of 12 was changed to a 2. So how many was subtracted then? If we went from a 12 to a 2, that means we took away 10. So we have our total scores of the scores minus 10 gives us 90. And we still have 10 people in the samples, so 90 divided by 10 equals 9. All right, let's try another one. A sample of 12 scores has a mean of 8. If one score is changed from 18 to 6, what will be the value of the new sample mean? So let's take a look. We have a sample of 12 scores and a mean of 8. The first thing that we need to do is figure out the total of all of the scores, which is 96. 12 times 8 is 96. Then we figure out what's the difference? What are we doing? We're actually subtracting 12 because we had 18 and then we have a new score of 6, which means we subtracted 12. So we take our total and we subtract 12 and we get 84. So we take our new total and divide it by the same number because we still have 12 scores, and that gives us a new mean of 7. Sometimes this is a little bit like mental gymnastics, but you've got this. You might want to just try it. Play with it a little bit. You have to maybe write it out, visualize it that way. All right. So in the next video, I'm going to speak with you about the median and the mode. See you there.